Hey y'all, Dr. G here. In the last video, we introduced the idea of using pressure in equilibrium calculations. And we use this reaction as an example. In this video, I'm giving you some information here, and we're going to use this information to determine three things. First, the equilibrium pressure of nitrogen. Then, the initial pressure of chlorine, and then our equilibrium constant. Okay, so the information that we are given here is that initially we have 3 atmospheres of nitrogen and 3 atmospheres of nitrogen trichloride. We don't know how much the initial amount of chlorine we have is. That's going to be one of the things that we want to solve for. We're also told that at equilibrium, the pressure of nitrogen trichloride is 4.25 atmospheres, and the total pressure is 6.125 atmospheres. So this is information that would be given to you in a problem. Okay, it'd probably be given to you in text format, word problem format, but from that you can glean all of this information. Okay, just like any other equilibrium problem where we know initial amounts and we are interested in equilibrium amounts, we should start by setting up an ICE table. Okay, so let's go ahead and do that. We have our I, C, E. Right, so just right out of the information we're given, we have 3 atmospheres of nitrogen initially. We have 3 atmospheres of the nitrogen trichloride initially, and we don't know how much of the chlorine we have. So I'm going to go ahead and just make this a variable, and I'll just assign it I. Okay? So this is going to be one of the things that we want to determine as we work through this problem. Our change is exactly the same as we've seen in the past. We have a coefficient of 2 here. So let's assume that the reaction is progressing towards products. Okay, so it's minus reactants and plus products, minus 2x, minus 3x, and plus 2x. As a reminder, the 2 here comes from the coefficient of 2, the 3 comes from the coefficient of 3, and the 2 comes from the coefficient of 2. Okay, and then our equilibrium line, we just add up our initial and change. So we have 3 minus 2x, we have I minus 3x, and we have 3 plus 2x. Okay, so that's our ICE table. We have information about the equilibrium pressures of each of our reaction substituents, our reactants and our products. We're going to be able to leverage this information to determine the things that we want. Okay, so let's look at what else we know here. We also know that at equilibrium, the pressure of nitrogen trichloride is 4.25 atmospheres. That's important because we also know that at equilibrium, the pressure of nitrogen trichloride is 3 plus 2x. So from these two pieces of information, we are able to solve for x, because we know that 4.25 atmospheres equals 3 plus 2x. So doing some simple algebra, we have 1.25 equals 2x. So x is going to be equal to 0.625 atmospheres. Okay? That allows us to figure out x, right? And x is important because it's a variable in the equilibrium amounts of our other 2 reaction substituents. Okay, and at this point, we're actually able to figure out the equilibrium pressure of nitrogen, right? Because the equilibrium pressure of nitrogen is 3 minus 2x, and we know x. So the equilibrium pressure of nitrogen is going to be 3 minus 2 times 0.625. So this is 3 minus 1.25, which is equal to 1.75 atmospheres. Okay, so as of right now, we know the equilibrium pressure of one reactant of nitrogen. That's one of the things it asks us to figure out, so we've already answered this question. We also know the equilibrium pressure of nitrogen trichloride because it's told to us in the problem. So we do not know the equilibrium pressure of our chlorine because we don't know the initial amount. So we can't calculate K yet. However, we can leverage the total pressure to allow us to figure out what I is. Okay? So let's go ahead and do that. Our total pressure is equal to 6.125 atmospheres. And we know this is equal to the sum of the pressures of all of the individual gases. So this is going to be equal to the pressure, the equilibrium pressure of nitrogen, which is 3 minus 2x. We've already figured out is 1.75. So it's 1.75 atmospheres, plus the equilibrium pressure of chlorine, which in this case is I minus 3x. We do know that x is 0.625, so we can get rid of the x here in a second, plus the equilibrium pressure of our nitrogen trichloride, which is 4.25. Okay, so quickly rearranging this, I have 6.125, I have 1.75, and 4.25. So the 1.75 and 4.25 together are 6, plus I minus 3 times 0.625. This equals 6.125. Okay, so we have 0.125 equals I minus 3 times 0.625. Okay, so I just took 6, subtracted from both sides. I'm now in a position where I can quickly solve for I. You're going to see here that the I is equal to 2 atmospheres. So the initial pressure of our chlorine gas is 2 atmospheres. So we've just figured this out. Okay, so we have both of these pieces of information now. We have the initial pressure of our chlorine gas. We figured out the equilibrium pressure of nitrogen gas. And since we know the initial pressure here, we know that I minus 3x is equal to our equilibrium pressure of chlorine. So we can pretty easily figure that out. We do our initial, 2 minus 3 times our x, which is 0.625. And this is equal to 0.125 atmospheres. Okay, so we now know the equilibrium pressures of everything we care about. Okay, and that's important because that then allows us to calculate our equilibrium constant. Let me go ahead and create some space here. So we know that our equilibrium constant looks just like it does using any other approach, right? So using it's the same as we see using our concentration approach. K is equal to the pressure of NCl3 at equilibrium squared divided by the pressure of nitrogen at equilibrium squared and the pressure of chlorine gas at equilibrium cubed. We know all these values. Nitrogen is 1.75, chlorine is 0.125, and our nitrogen trichloride is 4.25. So K equals our 4.25 squared divided by 1.75 squared and our 0.125 cubed. Okay? If you plug these into your calculator, you're going to see that the K value should come up to be around 3,000. It's 3,019.8. Okay, so that then gives us the last piece of information that we need. So just like every other equilibrium calculation that we've seen up to this point, think about the information that you're given and think about how you can use it. Today, in this video, the only new thing we saw is how to leverage total pressures. By leveraging total pressure, we were able to figure out the initial amount of our chlorine gas. And since we knew the initial amount, we could then figure out the equilibrium amount, which allowed us to figure out our equilibrium constant. In the next video, we'll go through one more example to hopefully help reinforce this idea for you.